Hi there, everyone, and welcome. My name is John Lynch, and this is our introduction video for our database design course, CS4092 for the full summer semester, so from May 6th to August 3rd. Um, I apologize if this came a bit late today. I had to set up some of my recording equipment and green screens, and it wasn't cooperating, but we should be good to go going forward. Before I delve into the syllabus and the PowerPoint that's here, I kind of wanted to give you a rundown of how the course pages look. So every time you go to a home page, there's some information about the layout of this course. It is a fully distributed learning course, so DL, so we'll be kind of asynchronous with our material, but that doesn't mean that we won't meet. So office hours are here, so if you're struggling with material or need more help, just come to these office hours at the Zoom link, or just email me. I'm usually available at any time, so just email me. We can set it up for other times too. If you go to the syllabus page, I have the syllabus as a PDF here and also just printed out as well. It's a little rough looking when it's printed out here, so I would prefer to download a PDF. So I'm going to go ahead and download that now just so we can look at it in a little bit. And another thing that I wanted to show you is that these assignments and quizzes should be available. Let me see here one more time. So I'll talk about this more in a different video once they're getting up there. But a lot of this material was for in person, so I'm translating it over to an asynchronous part. So it might take a little bit longer. So I just appreciate your patience with that. But I'll let you know through announcements as we go through it how it works. So you'll notice right away the first week is posted here. There'll be one more PowerPoint and video for more information after this one. The way that I kind of structured this is that there should be a checklist option inside of Canvas. So every time you click on these, I think it should automatically check it out for you. This isn't to be picky. I just wanted to give you guys an opportunity to see where you left off as you're going through some of these material, because there might be extra work or material going forward once we get into the meat of the course. So every time you look at the PowerPoint, it should put a check mark by it for you as well. This video that you're looking at now will be a hyperlink in these ones. So I know we have different types of learners here. So if you like kind of going out on your own and just looking at slides, you can just look at the PowerPoint. If you like a video walkthrough of me talking about it, you can look at these. Once we get into coding, I'm going to talk about the slides, but also put together some code examples that will be posted too, but I'll do them live during the video. So if you prefer live coding together, that's another way to look at it. And there's some information about a database design project and introduce yourself that I'll get into shortly here as well. So I'm going to download this PowerPoint if it works properly. Let's see here. Okay, great. And this is just kind of an introduction PowerPoint. Go through some of the aspects of it. Let me full screen it. And once we get to the syllabus, there'll be two books I talk about as well. But these slides are from Dr. Sioki Lee from University of Cincinnati, and also were adapted from Database System Concepts. I condensed a few of these, but if you need more information or more help, just let me know. I could put stuff together. So a very brief thing about me, I'm a PhD student in engineering and computing education, computer science education here at University of Cincinnati, and I started in 2022 of August. I was at DePaul University in Chicago. I actually immigrated here from Dublin, Ireland in 1999. So if I say a few words funny, that's why I like Tree or H. I got my bachelor's and master's in computer science, 2019, 2020. And after that, because of COVID, it was kind of more remote work, but I adjuncted at DePaul, Northwestern IIT in Chicagoland suburbs. My area was in software development, so I did a lot of full stack and app development, breadth of systems work too, so just kind of a bit of everything. But I'm pretty recent with my education from it, so I know some of the issues with it in that aspect, which is actually kind of my research focus as well. So I'm interested in mainly spatial visualization in CS. If a few of you did ENED, I think we all had to. It's kind of like those cubes that you rotated. So my advisor, Dr. Sorby, talks about those too. But I'm interested in analogies and notional machines for these complex CS topics and how spatial visualization can help with it. And you'll notice as you go through this course, these systems have a lot of overlap with visualizing what's going on. That's useful as well for us to try to figure out what's going on. Overarching goal again is to improve computer science retention. I was actually about to drop out during my bachelor's of CS, but I kind of persisted through it. So any issues or struggles with computer science, because I know it's a tougher subject, just know that I'm here to support you guys and to make sure to keep going through it. Great. So that's a bit about me, and now I'll kind of jump into what this course is about. So database management system, or DBMS, is pretty much a collection of interrelated data and a set of programs to access that data. So there's a few terms that you might have used, especially if you were on CLOPS before this, maybe like CRUD or ways to access databases. But it's essentially we're storing data and we're retrieving that data as well, and we can do that through simple command line operations or having a full application do it for us. And again, what's important here is that these databases provide persistent storage and a way to query that data so that it's useful to get back to us. And then, of course, if there's any hardware or software failures, and then concurrent access. So there's a lot going on underneath the hood. And even when you're looking at very simple systems, such as like making an account to log in and then just doing like a notes to do app, those have a lot of aspects of databases that are important for us to look at and are useful for really nailing how to do well with software development. So we're kind of in the information age nowadays and the age of data. So everywhere uses this database system. So from HR, universities, banks, and airlines. And the degree of severity to these changes quite a bit, but usually data is important to have. It could be kind of low level where if you're making like a one-off app and someone's profile can't be found, then it's a bit of an issue, but it's not the end of the world. But with airlines, if you're having issues with planes trying to land at the same time, that's where issues come up too. Universities might have some ways to deal with database applications too, such as students with the same names. My name, John Lynch, is very common. So sometimes the university's systems I used to work with mistook me for students as well. So there's some issues here where the applications need to be really secure and effective to pick them up. Here's just a few more examples of it as well. We could have grades and registrations, counting payments, HR. So you've seen all of these in your day-to-day lives already, but you might not have thought of them in the way of databases in the same way. So I think once you're going through this course, getting that into the back of your head is going to be useful, especially because there's going to be a project we'll work on. And just having this idea of how databases work in our real life applications will be helpful going forward. Yep, as I said earlier, airlines with reservations and schedules, online retailers. So Amazon is a huge database as well, with everyone using it as well. And then, of course, their GPS systems. Cool. So there's going to be two types of database systems that we're kind of looking at broadly. There's relational databases. So you might have heard of a few of these as well. SQLs are usually relational. And then we have no SQL or distributed databases, MongoDB, Google File System. So this one's pretty popular too if you use like a Python on Udemy or Coursera. Some of these are referenced as well. But in general, you can see here that the SQL, as this is no SQL, I don't want to have as many, is relational in the sense where all of our tables are going to be related quite a bit for it too, whereas NoSQL has a bit of a different under system to it. Now, as we go through the course, we'll delve more into these. But I think if you haven't seen any of these before, if you've only seen a few, you can take your time and kind of look at these as well. Postgre is going to be what we're going to be using quite a bit, but MongoDB is a free alternative as well. But just kind of get these into your mind, and you might have seen some other relational or NoSQL databases that aren't on here that could be useful to look at. Cool. So big thing with classes usually is why are we learning this and what's the purpose? Big one here is it makes you strong in the competitive job market. So hopefully when you're getting this degree, you either pursue master's, graduate education, or you go out into the workforce too, or if you're going through your co-op as well. There's this idea of a strong system aspect once you learn how these databases work. So there might be some complex and large systems that you need to deal with, but also this low level optimization that there is. So if you have this cache conscious algorithm, so essentially the way that data is being stored in at the underworking levels, and then how that gets combined into these larger systems, if you're aware of how to make that very strong, then it'll be very useful as well. There's also a theoretical foundation under these databases. So essentially, like how we query answers can become very complex, and there's also this expressiveness of these two. So in general, if you want to look at it through a pragmatic perspective, it's going to be useful in the job market. If you do things like full stack development with computer science, it could get you into areas like that. But also, if you're more mathematically inclined and you have these theoretical foundations, you could go to startups or some smaller application tools that want to use these databases, and you can kind of help them out with getting these complex queries going. Also, computer science is sometimes when you're learning it, you kind of do Python and you kind of do low level. You might do robotics as well as you're going through it, and then you can get into math as well. But a connection to all of these fields, as it says here, is that whatever you're doing in computer science, you're going to be using some form of data. So if you know how these databases work, then it's going to be useful regardless of what you do. So, we have this data mining, AI, and machine learning. You have hardware. So essentially, in the physical application where data will be transferred and how that works as well could be useful, especially if you're into computer engineering and getting into like low level systems of OS operation, or excuse me, like making your motherboards and everything. And there's also OS and file systems full of data too. So essentially, data could be king in this sense. So if you have a very strong foundational background in database systems, it's beneficial to you overall. Okay. So that's kind of the pitch of the course. So we're trying to sell it to you, but essentially, the topics that we're looking at here is going to be formal relational languages. This is going to be more to that theoretical one. If you're not too familiar, don't worry. We'll go through examples of it too. SQL, structured query language. So that's what that actually means. And essentially, we're going to be looking at how to code in these ones. So back on that previous slide where we saw the two sides, we're going to be looking at the left side a bit more. And then, of course, this database design. So there'll be an ER model, so we'll take a look at more, and we'll take a look at how that works inside of your project. But it's an entity relationship model, and a very basic one might be like a user has a username and a password, and then how does this relate to your queries? Okay, some normal forms of that too, and then of course transaction management. Great. So I'll go through a bit of this as well in the syllabus, but essentially we're going to be looking at how you can write SQL queries, how this relational language works, and this relational algebra, and this relationship between SQL and RA will be looked at as well. We're going to look at these kind of fundamental concepts in database systems, particularly recovery from failure, such as additional topics and sometimes like adding in data in the wrong places. And the coolest thing here, which is what your project will focus on, is this kind of real life application. So you have something to take with you after the course as well. So there'll be quizzes and a few exams throughout the course, but your team project that we'll talk about soon will be covered on that. This is for later courses as well. So there's a CS5151 6051, which is further past this one. So we're hoping to give you a pretty solid foundation in this course so that you can continue on with the other ones. And then we have this advanced database management. So this goes even further into your query optimization and like cache optimization that we looked at earlier. And this idea of concurrency control. Whoops, sorry. And that's going to be important too if you have these types of applications you're working on with a lot of things going on at once, and you want to make sure that versions are saved and that they don't interfere with each other. So like if something happens in two areas at once, how to deal with that. Great. So again, I showed you Canvas at the start of this information, but here's just some more information on it too. Again, my email is the best way to get in touch with me. I will be at office hours for these, but please go ahead and email me. Use any of these keywords. CS4092 is probably the easiest. Just put it at the very start of your email. And then again, if these office hours don't work for you, let me know. And then we could schedule one-on-ones at other times or whenever you need the help. Okay, so I'll also take a look at the syllabus for the workload with you as well before this one. We go down here. So it's a bit similar to what's shown on the PowerPoint, but your workload is going to consist of 4 homeworks at 5% each, a midterm and a final exam. These are going to be on Canvas for you at at a given time frame, so around 2 hours for it. There'll be more information posted on it. But there'll be information about study groups and everything for that too. But nothing that you haven't experienced before with midterm and final exams. It will just be on Canvas this time instead of in person. I talked a bit about this end of course project that we'll look at soon. So I'll go through that in a separate video that will be posted underneath a different module for the database design. And then there'll be quizzes in the in-person version of this course. They're activities, but I'm converting them to quizzes that you just can do on your own. And then that'll be for 10%. Okay. You have your letter grade here, 89 to 100's an A, and so forth for these. Excuse me. And there's a tentative course schedule here for you guys. So this course is usually a 16-week full semester. So I'm condensing it into because we only have like 12 weeks really, smaller ones. So things are going to happen a bit faster back to back. For instance, there's usually 2 weeks of introductions and maybe a week and a half of intermediate. It'll be a bit shorter, but essentially what this is telling you is on the date of this, you have the topic that will be released on Canvas, and then a note will be what occurs that time as well. And these are positioned for the first of each week. So today is the 6th. So every Monday of each week, new information will be released. So that will give you the 28th is when homework one will be posted. And then usually we'll have you'll have the full week to finish up everything that's on the module. Okay. So I'll jump back into my um, slide one more time here. So oops, that's essentially what the workload is as well. And I have a bit more information here about this course project. So we have 72 total students in this class online. I made these teams inside of Canvas that you can self-enroll in. And there's also this discussion board of introduce yourself that you'll see posted there. Okay. So what I would like everyone to do, either after watching this video or going through these slides, is to try to introduce yourself as soon as you can onto the discussion board. If you have other people you know in this class already, reach out to them. You could self-enroll inside of the team. So if you go into people, show you here. So I'm in a student account right now. If you go into people and you hit groups, see here, there should be some groups in here that you could join into. I'll have them unlocked for you to join, but essentially you'll have these groups that are open, and then you could just pick one to enter into. Okay, so if you already have a team that you kind of want to work with, just pick that out. Or what I would say is introduce yourself, see if there's some people on the lines that you want to work with, and then go from there for that. Okay. One more thing is that these pieces of the project will be introduced throughout the semester as we learn new things, but the whole project is posted right now. So if you want to get a head start, you can look at it. The reason I post these early is that this course is condensed. So you want to kind of make sure that you take your time to read through all of that. We're going to be doing a submission through GitLab repositories. There's going to be a separate video talking about that too. But essentially, once you have your team made up by the by the next week after the 12th, I'll make repositories for everyone, and then I'll send them out to each team, and then you can kind of use that for a way to save your information. If you want to create an account using GitLab with your UC email, that'll be useful going forward too. If you're not familiar with these, there's a link here to go through. And if you need more help, just let me know. But if you aren't familiar with GitHub too much, I would recommend getting familiar with it because it is useful going forward with the tools it gives you. Okay. Oops. So I'll go into that was the old slide there. I'll edit that. I'm going to go into your database design project really quick. Okay. And essentially, I'll have another video that goes into the details of these, but in the timeline of your PDF that's here, there will be a few deadlines. So by July 8th, there's going to be an entity relationship model due. There will be some SQL scripts due by July 15th. The implementation due of your project will be due July 22nd. And then a 5-minute recorded video is due July 29th. Okay. So these are strict deadlines that you want to try to meet. But of course, issues with teams or anything, just let me know. And I'll reach out and figure that out with you too. I think the biggest thing that I wanted to reiterate with this course, especially as we are online, is to just make sure you keep in contact with me, either attending the office hours if you need extra help, or if you just have issues with your team, just let me know. Okay. These two slides you can ignore. I'll go ahead and change that in the final slide. What I also want to do is talk a little bit about your PostgreSQL. So this is an open source relational database that adheres to the client server model. So essentially, we'll talk more about that once we get into the next PowerPoint. But essentially, open source allows you to get more information from it. And this relational database means that your service could be connected through types of queries that are in there and your indexes. Okay. We have clusters inside of Postgre as well. So those are going to be a collection of databases by a single instance of a running database server. So of course there's one like large server and then there's clusters inside of it. And then we'll have a server itself, which manages your database files, connects to the database from the client, and then we have actions sent from the client for it too. So those CRUD operations I talked about earlier will be handled by the server for you. Okay. So there's two commands on here, the GUI pgadmin. If you want to take a look at this link, this will get you set up with PostgreSQL. And then there'll be a CLI, which is a built-in command line, which interfaces with PSQL. So if all this is very unfamiliar with you, don't worry. We'll go through it ourselves in videos. But if you're a bit familiar with these, you could probably just get started for it too. Okay. So, oops, sorry. Going off this PostgreSQL, what I would say is you can get your downloads for the client and the server from these two links, and you can use some source code here too. These links are in your PowerPoint if you want to go ahead and open them. I'll run through a version of this ourselves once we get it posted. But what I would say is go ahead and get used to it, create a cluster, start stop servers, and then try to run some CLI commands such as PSQL to see if your server is running, okay? So we're kind of using a mock version of an actual server where you're the client running your client code, but you're also running the server for it as well, okay? One more thing is I don't have a TA for this course, so it's just me, and there is 72 of us in total. So I'll try to get back to you guys as soon as I can, but please use the office hours. What will be useful too is that sometimes if I'm helping students and they're in the same office hours, you can kind of bounce ideas off of each other or look at other people's attempts at things. But just please let me know if you need more help. And there's also a discussion board. These should be posted. So this is your introduce yourself that I would like you to post on, but there's also discussion boards for homeworks. I'll be monitoring these, so just don't post the answers right away. What these will do is just, as I say, a discussion board. So if you're very stuck with an assignment or you don't really understand what's going on, you can put up your question here. And then if someone kind of not maybe gives you the answer, but helps direct you to the answer, just make a note of it. So I don't think you're just like copy pasting for it as well. Okay. There is two reading materials that I forgot to look at in the syllabus. The slides were kind of a combination of these, so you don't need to read these verbatim. If you prefer that, there are two links to each of the books inside of your syllabus. So if you go up to, where was it? Course resources, you have your first book here as a link. This is kind of more of a full website that talks about it. Then you have your second one here, which is a complete book, which is around, it's 1,200 pages. I know we don't have that much time in our week, so knock yourself out if you want to try it. But this is kind of based off of what the slides use these too. But if you feel very stuck or want further information about a concept, feel free to use these books. Okay, great. So as a little recap from this entire video, what I would say is go ahead, get through your checklist, start introducing yourself, and take a look at your database design project, and there'll be more videos to come. All right, thank you, everyone. I'm excited for this semester.